Hi everyone. Now we will introduce the inference about the means and proportion with the two population. A few weeks ago, we had introduced the hypothesis test in one group or in one population condition. Now we will introduce the condition in two population or in two groups. The first one we would like to introduce is the inferences about the difference between the two population means sigma 1 and sigma 2. They are known condition. Okay, in such condition we will use the mu1 as the mean of the population 1 and mu2 as the mean of population 2. So if I ask what's the difference between the two populations mean, then you will say yes, you can directly use mu1 minus mu2 to talk about the difference between them. But sometimes it will be difficult for you to collect all the information from the population, so you will do some sampling. Okay, so select a simple random sample from a size of n1 from the population 1 and do sampling for the sample, okay, from the population 2. Then you will calculate the mean of the sample. For example, here S1 bar as the mean of sample 1 and S2 bar as the mean of the sample 2. So if I ask you what's the difference between the two populations if you use such sampling, then you can say you can use S1 bar minus S2 bar on behalf of the estimator, okay, for the difference of the population 1 and population 2. So here we can use an example from your textbook. It's a Greystone department store. They open the two stores, okay, in different city. One is in inner city and the other is in suburban. Okay, so the regional managers, they notice that products that sell well in one store may not sell well in another. So that he or she notice there may be some difference among the customers into different store or into different city. So customers may differ in their age, education, income, and so on. So suppose the manager, they will ask us to investigate the difference between the mean ages of those customers at the two stores. Then what will you do? Okay? So in such condition, you will know there are two stores for the Greystone department store. So one is in the inner city, the other is in the suburban. Those are the population for you. But if you would like to do the experiment to know the difference, you will do sampling. For example, random sampling. Okay, to get the mean from the sample. Okay, for the stores. For example, we will use S1 bar as the sample mean age for the inner city store customers and S2 bar as the sample mean age for the suburban store customers. Then we will minus them to get the points estimator from the population 1 and population 2. Okay, so in such condition, you have to learn, in addition to the difference between the mean of the sample or the populations, you have to know because you do the sampling, so it's just an estimation. So when you would like to express the difference between the two stores, it's not only to tell them the difference of the mean, you also need to talk about the margin of error. So in order to talk about the margin of error, you have to learn the standard error of the point estimator from the S1 bar minus S2 bar. So it would express like this one. Okay, you would like use the standard deviation from population 1 and 2 and the sample size from population 1 and 2 and to calculate out the standard error of the points estimator of S1 bar minus S2 bar. So here we would like to do an assumption, that is, if the population have a normal distribution or the sample size, you do the sampling, okay, sample size are large enough, it will base on the central limit theorem. Then we will say the distribution of the S1 bar and the S2 bar, they could be a normal distribution 1. So because it is a normal distribution 1 from the mu1 or the mu2, so that also means the sampling distribution will also follow the normal distribution. Okay, so when we know it is the normal distribution, then you can think about how to express the margin of error. So here you would say, yes, the difference between the population 1 and population 2's customers, you will directly say the difference between them. But because you do it is by sampling, for example, random sampling, so it will be an estimator for estimation for you. So it will result in the margin of error. So here you have to learn how to calculate out the margin of error. So the interval estimate for you to express the difference between population 1 and 2 will be more accurately or then you just say the directly the difference between the two populations. Okay, so here the margin of error you would like to do it is from you need to use the normal distribution to get the z-value from it. Okay, so here you have to think about what's the confidence coefficient you would like to use. Then use the half alpha of z-value and multiply by the standard error from S1 bar minus S2 bar. Okay, then it would be the margin of error for you. Then you will add the point estimate, okay, or minus the margin of error to get the interval estimation. So here, go back, okay, go back from to our example. You will find the sample size from the inner city store is 36 and from suburban store is 49. And the sample mean for them, S1 bar and the S2 bar, one is 40 and the other is 35. So the interval estimation for you to express the difference between the two stores, what you can do, okay, follow our formula you learn for the interval estimation. The first one, you can directly to say the difference between the two stores, use S1 bar minus S2 bar to do the point estimation for the difference between the two stores. Then you have to do the margin of error. Okay, today you would like to use 95 percentage confidence to express such condition. So the alpha is 0.05 and based on the formula of the margin of error, you have to calculate out the z-value of the half alpha. So you have to check the z-value table is 1.96. So you have to multiply it with the standard error of the S1 bar minus S2 bar. Okay, so you will use the standard error and the sample size from population 1 and 2. Then finally you will base on such point interval estimation with the point estimation and the half alpha value of the z, and then to get the standard error from the S1 bar minus S2 bar. Okay, you will get the interval estimation that is 5 at or minus 4.06, and the 4.06 is the margin of error. So here you can say you have 95% confidence to express such interval for the difference between the two population means, that is, it may between the range of 0.94 years and 9.06 years. So that's the point estimation for and the margin of error to express the interval estimation for you.